Alright class, this is the last video for this the unit, linear programming. So we're going to take what we did yesterday and come up with our constraint equations and then graph them and figure out our feasible region and then test the points to figure out where maxes and mins happen. Okay? Yesterday I gave you I gave you graphs where you already had the shaded region, you just had to test them. Now we're going to do everything together. So let's look at the problem. Go to the store to buy new pairs of socks. You want to buy at least 5 pairs of socks. Red socks cost 4 and striped costs 5. You only have $30 in your pocket. X represents red pairs, Y represents striped socks. So right away, first equation has to be how many we can buy. So that's going to be X plus Y at least 5, which means this has to be bigger than or equal to 5. Then we're going to do the price one, which means there's $4 per pair of red socks and $5 per pair of striped socks. Now, however, that has to be, we only have $30, so we can only spend up to $30, which means the 30 has to be the biggest thing. So that's how the inequalities will look. Now we have to graph them. Now, you can either solve it for y and do slope-intercept form, or you can do the cover-up method, where you set each piece equal to 0 when x equals 0, y equals 5, and vice versa for this one. And just solve for standard form. So we know the first one, the blue one, is going to go from here to here. Okay, and then it'll just go with a slope of 1. And we want x plus y to be bigger than 5, so that means it's going to be this way on the line. Now we have this one here. 4x plus 5y is less than or equal to 30. If x equals 0, y equals 6, and if y equals 0, 30 divided by 4 is 7.5. So I'm going from 7.5 up to 6. Now in this case, just get a straight edge and kind of make the straight line. But we can't go higher than that line because we only can spend up to $30, and that line represents $30. So that means that if you test 0, 0 is less than 30, that's true. So we're shading this way. So basically our feasible region is this region. So these are all my points that I care about, and we'll deal with those in a minute. Under these conditions, could you buy 4 pairs of red socks? And I better label this. Red is X and striped, so I know. Can we buy 4 pairs of red socks and 1 pair of striped socks? And that is actually yes, because that gives us the 5, and it also fits lower than our cost. It's on a solid line. So that would be a yes. You decide to only buy Y striped socks. What is the maximum amount of money you will spend? Well, the maximum amount of striped socks that we can buy, it looks like, is 0.6. So we can get 6 pairs of striped because of the point 0, 6 is the highest point in the region. And then that would give us, if we know that it's $5 times every pair, we would spend our max of $30, and that's why that's the top of the region. So we would spend all of the money. Why do we only need quadrant 1 of this graph? Well, hopefully you guys realize that we're not going to be buying negative pairs of socks. So only buying positive quantities. Of socks. Okay, so that is that problem. We've made our region. We answered the questions that were important. Let's go on. Bella is going to the bookstore to add to her book collection. She can buy either hardcover or paperback. Wants to buy 10 or more books, but can spend only up to 48. So this is very similar to the last problem. X is hardcover, Y is paperbacks. So I am going to come up with my inequalities. The first one states that you have to buy 10 or more books, so X plus Y has to be bigger than or equal to 10. We want it to be more than 10. But with the money, she can buy hardcover for $5 and paperback for $3. That cannot go over 48. So there's our new equation. Okay. So now I'm going to graph these lines. The first line is x plus y equals 10. Again, if x equals 0, y equals 10. And if y equals 0, x equals 10. And usually with the x plus y equals a number, it just is a slope of -1. Now for this next one, I might want to find the actual slope, or I might just connect the dots. No, I'll find the slope. This one I'll solve for y, so I get 3y. Oh, I should probably actually graph the line here. Okay. And by the way, I want to be more than that, so again, the shaded region is going to be above. And then we have here 3y is less than or equal to 5x plus 48. Y is less than or equal to 5/3 x plus 16. Okay, so if I want to graph this, I start at 16, and then I go down 5, and over 3, down 5, over 3, down 5, over 3, and there's the point that they hit, and then that's it for this line. Hit somewhere there. And we want to be below that but above the blue line. So our shaded region in this case is this region right here. Again, we need the common points. We have this common point, and this common point. So we have 3 points that we are looking at for this problem that are on the in the region. Okay? And now we can figure out these questions. Under these conditions, can Belle buy 3 hardcover books? Oh, by the way, X is hardcover and paperback. So 3 hardcover and 10 paperback books. So if we look at 310, 310 is in the region, so yes. That point is inside the feasible region. Okay. What are the maximum number of books Belle can buy? How much will that cost? What types of books will they be? Well, let's think about this. We have to look at this region. Like down here we have 9, 1. That's only 10 books. Here we have 10, 0, or 0, 10, which is 10 books. Here we have 16 books up here. It also looks like we might be able to do 1 and 14, but 1 and 14 add up to 15. So for me, it looks like the best we can do in terms of total amount of books is this point right here, which is 0, 16. So how much, what are the maximum number of books Belle can buy? Total, she can buy 16 paperback. And when you do that, you get 3 times 16, which is equal to 48. So she can use all of her money to buy only paperbacks. Okay? What is the maximum number of books Belle can buy if she buys both paperback and hardcover? Alright, so this is where I look at, again, I kind of move along this red line, and we kind of talked about it. You have to use whole units, so I can't say she could buy 1 and 15, because that doesn't work. But it looks like she can buy 1 hardcover and 14 paperback, which gives you a total of 15 books. And if you go lower, that number will decrease. So it looks like she can buy 15 total, 1 hardcover, and 14 paperback. And if she does that, how much will she spend? She'll spend $5 for the hardcover and 3 times 14 for the paperback, which gives you $47. So that is the final total. Alright, let's do one more. This one's a little bit trickier because there's more involved. We have a furniture manufacturer makes chairs and sofas. So right away, X is chairs, Y is sofas. Okay. You know that because that's what they're making. Also, you can look at part B, and it says there's a profit per chair and per sofa, which means that we're going to have to use those for our values for X and Y. So number of chairs, number of sofas. So we get, and these are all our constraints based on the material. So the manufacturer has room to store 1,800 packages of stuffing and 800 packages of fabric, and you have to maintain at least 2,400 packages of wood. So we're going to have three equations based on those three pieces of information. So for the wood, it takes 3 boxes to make a chair of wood, plus 8 boxes of wood to make a sofa. And this one says we have to have at least 2,400. So that's going to be greater than or equal to 2,400. The next one says stuffing. Again, we have 3 per sofa chair and 3 per sofa. And now this one for the stuffing, if you read the thing up here, it says that you can store up to 1,800 packages of stuffing, which means that this has to be lower than or equal to 1,800. And finally, we have the fabric, which is 1 and 2y for the sofa. And again, we can only store 800 packages of fabric, so it is less than or equal to 800. So those are my 3 equations. So we have to graph these. Now, if you are curious about how to make your window or your axes, maybe do the XY thing again. So for this one, when x equals 0, y equals 300, and when y equals 0, x equals 800. So I have to go to 800 and 300. What's the other thing? Okay, so then I look at this next one. When x equals 0, y equals 600, and same thing for the other way. And when I look at this one, x equals 800 when y equals 0, and when x equals 0, y equals 400. So it looks like I need up to like 800 on the axes. So I'm going to do that right now. And I think these go 20 across. So I'm going to make each one 50. So every 2 is going to be 100. $400, $500, $600, $700, $800, $900, $1,000. And then this is number of chairs. And then the same thing going up. Every 2 boxes I'm going to make 100. Number of sofas. Okay, so let's start plotting our equations. The first one has the point 0, 300 and 800, 0. So 0, 300 is right here, and 800, 0 is right there. So if you draw this, now what you can do is see that it's 3 over 8 total if you divide 300 by 800. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. And you can get that point. That helps at least draw it a little bit. Alright, so there's that one. Now this is the one where you have to be above this line because it says you have to be greater than or equal to 2,400 with the wood. So that's going to be shaded up. So we'll deal with that in a second. The next line we have is the 600 to 600. So 4, 5, 6. When y is 600, x is 0, and when x is 600, y is 0. And this has the slope of 1, so I'm going to just put the dots in. Okay. So we draw this one in. Okay, we don't know this point because it's not a nice point yet. We're going to find that later. By the way, this has to be lower than this, so we're in there so far. And then finally, the stuffing, or the fabric, is 800, 400. So the x is 800, the y is 400. So if I graph that, we start here, and the x is, no, I lied. we're not starting there. We're starting down here at 800 where this one is, and we're going up to the 400. So that's a slope of 1/2. So I'm going to find that point there. Okay, so here's this one. Now, we also have to be below the green line because we can't go over the 800. So our feasible region is this region in here. Because we're below the blue, we're below the green, we're above the red. And be careful, it goes all the way to this corner here. Okay, so we have a couple points now. We have points that we have to look at. We have this point, which is 0, 400. We also have the point 0, 300. I'm just looking at all the points. We have this point, which is a perfect point. It's 400, 200. Now this point is not perfect. We're going to have to find that point. And that's the intersection of the first line and the second line. So what you could do in your calculator if you wanted to, we want to find where these two equal each other. Okay? So you can do two things. You can set one equal to the other and solve. First, actually, let's come up with the profit, though. If I want to know the profit, we get $200 per X and $350 per Y. So that should just be that. Now, to find the intersection of these two, the first one and the second one, you can set them equal to Y and solve. So, for example, we get negative 3X plus 2400 equals 8Y. Y equals negative 3/8 X plus 300. That's one equation. And then the other equation is 3y equals negative 3x plus 1800. Y equals negative x plus 600. And then you can solve by setting those equal. When you set negative x plus 600 equal to negative 3/8 x, and you can use your calculator for this too as well. You can graph both these lines in your y1 and y2 and then solve. Plus 3/8, so you get 5/8. Negative 5/8 equals negative 300. Oh, sorry about that. They're doing some construction right next to me. Oh, sorry. I don't know. Well, I'll just keep going. And all right, sorry about that. I had to wait a bit until they were done. So anyway, when you solve this equation, you get x is equal to 480. And then when you plug that back in, you get y is equal to 120. So that point down here is where those two lines intersect. This point right here is 480, 120. And now all we have to do is find out where they would maximize their profit. So we can test each point. So I'm going to do that right now. So if I'm testing the point 400, 200, that's one of the points. You get a profit of 200 times 400 plus 350 times 200. And you get a profit of $150,000. So that's the first number that we're going to look at. If I check point 480 and 120, that's the one we just found. I'm going to get 200 times 480 plus 350 times 120. And if you do the math, you get 138,000. So that is not as good as the first one. The third point is 0,300 and 0,400. Well, if you look at it, hopefully you guys can see that 0,400 is going to be better than 0,300, just because it's, you know, are you going to make more profit if you sell 300 or 400 sofas? Well, hopefully 400 if there's an extra 350 per sofa. So if you recognize that, really you only need to test the 0,400 one just to see what the profit is. And it's 350 times 400, which is actually kind of close. It's 140,000. So the max is at 400, 200. So they should make 400 chairs and 200 sofas to maximize profit. and that profit would be $150,000. And that is it. Sorry this video is a little longer, but it's a little more involved with the graphing. And yeah, last one for the unit.